Hello, good afternoon, everyone. I'd like to welcome Mahmoud Dabbous. He's actually one of my colleagues from university, one of my good friends, to do this workshop for you guys today about synthesis and about sound design, and more specifically modular synthesis. Uh, I think there's a range of people here, start beginners and people who are already producing music. So I think this is a very interesting topic for you guys to learn. I'm not going to tell much about Mahmoud. I'm going to let him begin and introduce himself and get the session started. If you have any questions, or prashna theeranam, please, you can type it in chat or raise your hand, right? And you can we can put that in, right? Uh, and I hope you all enjoy the workshop and you know have plenty to take away today, right? Mahmoud?
Hello, everyone. Thank you very much for having me. Thank you, Max. Today, we'll be talking about sound design. A little introduction about myself. Uh, I am a system engineer by day. Uh, I work for a company. We are a distributor for some popular audio brands: Sennheiser, Mayer Sound, Neumann, Electro Voice. And in my free time, I do sound design. I do music using synthesizers. I'm fascinated by them, and hopefully today I'll be able to give you some insight about synthesizers, especially Eurorack synthesizers, modular. So let's get started. I'll share my screen. So today we're talking about sound design. So first of all, we need to define what sound design is. It's the art of creating and manipulating sound for artistic or functional purposes, which you can use in music, in film scoring, in gaming, and in theater. A synthesizer is an electronic instrument. Okay, it keeps on generating waveforms all the time. You can think of it as sculpting waves. It manipulates the sound to create music. You can create a wide range of tones and effects by combining and shaping waveforms using controls for pitch, volume, timbre, and modulation. You have several formats for synthesizers. You have digital synthesizers. The one I'm showing here is Serum. It's like one of the best, in my opinion, one of the best synthesizers, digital synthesizers that you can work with. You have hardware synthesizers like the famous Nord Lead. You have Moog. You have countless brands, uh, and you have the Eurorack format. This is my system. That's my first system. Now it grew, but unfortunately, that's the only decent picture I have because I live in a different country and the system is back home, and I'm planning to get it. So grew bigger now. It has two more rows and more modules. First of all, you need to understand what's the basic block or what's the basics of creating sound, which is called harmonics. You have a sine wave, which is the very basic block of sound synthesis. Uh, a sine wave basically will make your driver move in the shape of a sine wave back and forth certain amount of times per second, so it will create a tone. Harmonics define the timbre, tonal quality, and is it's what's get created when you start adding sine waves together. So what you see now on the left side is a sawtooth wave. Sawtooth wave is created from a lot of sine waves, and I would demonstrate that in a second. But if you see, you have at every frequency and every double of that frequency, you have a harmonic. Each peak It's called the harmonic. So if you are starting with a bass or a root note or a root frequency of 200, so you multiply that by 2, you get the second harmonic. You multiply it by 3, you multiply the root note or the root frequency by 3, you get the third harmonics, and so on. So just a little demo. Please, I'll play a tone, so adjust your headphone levels, please, because it's a sine wave, it's not very pleasant to hear. Can everyone hear my sound? My computer sound?
Yes, I can hear it.
Okay, so this is a single sine wave. And as you can see here, you have the ability to add first harmonic, second harmonic, third, fourth, and so on. So let's watch the wave whenever we start adding another sine wave at double of that frequency, 3 times that frequency. So I'm using a base frequency of 220. Let's play a sound. The more you start adding for a sine wave at the second harmonic, which will be 440, because as we said, you multiply by 2, so you take 220, multiply by 2, that's 440. The third will be 220 times 3, and so on. The wave keeps changing. The shape of the wave keeps changing, and the tone keeps changing. So this is, in a nutshell, what happens when you start adding more sine waves. Any waveform that you will find on any synthesizer is a group of sine waves being mashed together, and when they are added together, they create something new out of it. You have, let's say, 4 basic waves that you can work with, which is the sine wave, the square wave, and the square wave is only adding odd harmonics. So first harmonic, you skip the second, you add the third, skip the fourth, you add the fifth, and they have a mathematical relationship in terms of amplitude, which I won't go in now, but you need to know that it has a certain relationship between each and every harmonic. When you add them, you start having a square wave. You have the triangle wave, which adds first all harmonics only. You have the sawtooth wave, which you have all the harmonics in it, first, second, third, and so on. This is how you start creating or starting with the building block of the sound. You choose a wave and you start working your way up from there. You have 2 approaches. One of them is called the East Coast, which was created by Moog, and it is a subtractive synthesis focus, which means that you start creating sounds by removing frequencies or removing harmonics, using filters, using volume, and a typical signal chain will have an oscillator, a filter, some envelopes, and the traditional application for it is melodic synthesis. You have another company that's called Buchla, and it was in the West Coast, and they approached sound design by using additive synthesis, by adding harmonics, not removing harmonics. So you create complex waveforms. It's more experimental, more generative. It uses something called function generators that we will take a look further in this presentation. It uses something called low-pass gates, which is basically a low-pass filter, but works on a faster speed. Like it's so fast, even like computers can't properly recreate it because it needs certain circuitry to do that. They use something called FM and AM synthesis that we will explore, which is frequency modulation and amplitude modulation that we will see later on in this workshop. Let's start by building a modular system. First of all, you need to plan for your system because you have no idea. There are hundreds and hundreds of modules out there. Unless you have millions of dollars that you are willing to spare to buy them all. You will need to understand more what kind of music that you're looking for, uh, what kind of textures that you want to get out. Let's say, for example, you make techno music, so you're looking a lot of melodies, you are looking a lot of sequences, or you are doing, let's say, atmospheres for games. So you need more effects, you need more oscillators working together. Maybe you don't need a Eurorack system at all because what I'm going to say now, it's just my opinion because the whole idea of a modular system is to have the freedom to do whatever you want. But for example, if you like synthwave music or you like a certain sound that's being created in music using a Jupiter or a Juno, maybe Eurorack is not your thing. Maybe you are looking for a different kind of synth. So you need to understand more about what's your sound, what exactly you want to do. And even you need to know that if you will use Eurorack so you can build your own rig, because you will never find two systems. It's like fingerprints. It's linked to you, to what you want. Every system is different than the other because you pick and choose what synthesis, what modules that you want to work with. So you need to understand first your goal, then you need to choose a case and a power supply based on the Eurorack specs because each module draws certain amount of power and you need a power supply that can supply that demand of those modules, and a perfect website for that is modular grid. Like you can create, you can choose the power supply, you can choose the case that you want, you can choose the modules, and it will tell you exactly how much power you need and how much left in your power supply, so you can plan ahead before you start trying to understand more what you want. And for beginners, I would always recommend a semi-modular approach. A semi-modular approach is a box that has the basic components that you will find that you will need to have a modular synthesizer up and running. You don't need to spend a lot of money to buy some modules. You can buy this synth. For example, the Behringer Neutron is the one of the is my first synth that I started with. Uh, and if you like it, the face panel can be removed and it can be fitted inside a case, and it works perfectly fine. You can use it as just to start to see if you actually like the modular uh, discipline or you don't like it at all. You have the Make Noise Zero Coast. It's such an amazing synthesizer, and it also can be fitted inside the case once you have a bigger system. Installing a module or installing a Eurorack system, it's not rocket science. You just need to be aware of some stuff. It uses ribbon cables. You will need a power board, which is you will, if you buy a case that has the power supply in it and the bus boards, it will be inside of it. So all you need to do is to attach the ribbon cable to the back of the module. Just a moment. You will attach it to the back of the module, and from the other side, you will attach it to the bus board. But you need to be aware of something. The You need to connect the positive side to the positive side and the negative side to the negative side, because if you cross wire them, so you lost some dollars. So basically, most of the modules now they come shipped with the ribbon fitted inside, like it's only already plugged for you from the module side, and you need to plug it into the bus board. And nearly all of them now will tell you that because the ribbon cable has a red side to it, and you will see here it says red, so you cannot miss it. And on the bus board itself, it will say the red stripe over here, so you can crosswire it by mistake, or you will fry your module. This is a normal case. It has rails on top of it. You just screw the module on top of it, and you are ready to go. You have three types or three formats for modular synthesizers. The one that's the industry standard that everyone is using is called a Eurorack format. It's a 3U height, three studio units height, and which is 128.5 millimeters. And the width is measured in a unit called HP. Each HP is 5.08 millimeters. So, for example, on the data sheet of a module, it will tell you that this module is 13 HP. So you will do the math, you will know how many millimeters you have, and normally the cases already comes in, like it's in the data sheet of the case itself. It will tell you that this is an 84 HP, for example. So you just do the math, you have 84 HPs, you get modules that will add up to that amount of HP, and you're good to go. Eurorack modules use 3.5 millimeter patch cables, and the power supply provides positive 12 volts and negative 12 volts because you can go positive values or negative values, and another port for plus 5, which is needed for some other modules. So this is called the Eurorack format. You have another company that's called Buchla, which created the West Coast synthesis. It uses very unique voltage standards, and they use, instead of normal note input, they use another values for that. And they use something called a banana connector, which is not 3.5. It's oddly shaped, and Buchla synthesizer is too expensive. That's if you even can find one, because they are very rare to find and they are too expensive. But luckily, there is a company called Tip Top Audio. They collaborated with Buchla, and they made some uh, old Buchla modules, legendary modules in a Eurorack format, and it's cheap compared to a Buchla system. So that's something that everyone was looking for recently. You have the last format, which is the Moog modular. Uh, it's a very old format. It uses 5U, 10.5 inches panel height, and the patch cables are quarter-inch cables, and it's made by Moog. If you can find an old Moog system, it's very, very expensive, and it's very hard to find. Hans Zimmer have a huge wall full of Moog synthesizers. So those are the three main ones. Today we will focus on the Eurorack, which is the everyone is using these days. Uh, and let's dive into it. You have two things that you need to be aware of: the voltage and control voltage. Control voltage is, let's call it a modulation signal, or not a modulation signal. It's a voltage that you can control inputs with. If you, for example, you want to move a cutoff of a filter by a certain amount, and you have both of your hands are busy doing something, you can apply a voltage that's constantly changing, and it will keep changing the knob according to the shape of that control voltage. As the definition says here, it's an analog signal controlling parameters like pitch, modulation, all sorts of things. And they typically range from 0 to 10 volts or plus or minus 5 volts for bipolar signals. You have gate voltages and trigger signals. You can think of them as buttons. Gate signals is a trigger, is a pulse that you can use to tell something to work, like as if you're pressing a button on something. You have two forms of them, and we will see the difference between them. A gate has a longer period of it in high voltage, or a trigger that's a very brief pulse to initiate actions. You have something called clock generators, which is a module or a machine that creates triggers and gates, and you can think of it of the maestro or you think of it of your main BPM, and it will spit out signals that you can use to activate modules or to change some parameters. Uh, yeah, I can have physical buttons that can create clocks and triggers. You press on a button, it creates a trigger. You press on a button, it starts a clock. So those are the triggers and gates that you can use in a modular ecosystem. Let's talk briefly about the components. I'll mention the components very briefly, and we will see them in action where we will talk more about them. But I just want you to be familiar with the terms. You have the core modules, which are oscillators, filters, envelopes, and VCAs. Oscillators is an audio source. It keeps creating sound waves, sine, square, saw, triangle, and it uses something called 1 volt per octave as the for the pitch or for the notes. So let's say from C0 to C1, that's a range of from 0 to 1 volts. So let's say the C0 is 0 volts. Let's say C sharp is going to be 0.2 volts. D is 0.3 volts, and so on until you finish an octave, and the second octave is from 1 volt to 2 volts. This is how oscillators recognizes pitch. Filters, I suppose everyone knows about filters. It's like EQs and normal filters and EQs. It just shapes the sound by removing frequencies, low pass, high pass, band pass. You have all sorts of filters. You have envelopes, ADSR. It controls amplitude, and you can use it for modulation over time. You have VCAs, which is voltage controlled amplifier. It's an amplifier. You put a signal in, and it will control the amplitude of that signal. It can be used to control a level of an oscillator, or it can be used to control how much of a modulation signal is going to its destination. You have data conversion modules, and this is very useful for hybrid systems because you will find a lot of arguments on the internet. You have the purists that will only use modular synths, complete analog, who does not want to open up to the idea of using a digital system with it, and I completely respect that. But my personal opinion is that why, if I have the best of both worlds, why not use them together? So if you have a data conversion module, it usually uses a USB or an ADAT connection through your audio interface to interact with your module rig. You can, and now Ableton, for example, and you have some plugins that you can find on Cubase and Pro Tools, but Ableton and Bitwig natively, they have some plugins that can control modular systems. You can send pitch, you can send envelopes, you can send LFOs, you send and receive audio. It's very useful. You can have a very dynamic working ecosystem. If you work with a computer and you work with a modular rig, you can make both of them talk very nicely together. And you can have a data conversion module that converts from MIDI to CV. Let's say you have a modular rig and you want to use a MIDI keyboard to control the rig. You just get your normal MIDI keyboard, you plug in into the data conversion module, and it will convert the MIDI information into control voltages, and you can use them to control various parameters in your rig. You have control and modulation modules. You have LFOs, which is a low frequency oscillator, and it's an oscillator that works below the human hearing range. And it's lower than normal oscillators, so you can use them to start moving around parameters. Or you have something called function generators, which is, you can call it envelopes on steroids. It creates various shapes, modulation shapes that keeps changing all of the time. So instead of having one boring movement on one knob, you can have a parameter that keeps changing and evolving all the time to create interesting patterns or interesting modulation. You have sequencers. Sequencers are modules that generate sequence of control voltages or pitch information or gate signals as well. Have something in the chat here. I think. So there's a question here. Can we use the formats interchangeably, such as using a Moog with a Eurorack filter? There are some adapters, but there's no point if you will get one Moog module and you will have Eurorack modules. Why waste money? Why not get the same system? So they all, because uh, the values will be different. So you want to do something here, it will not reflect as you want. Uh, like my point of view is you will stick to a Eurorack format, stick to it because they will play nicely together. You will use a Moog format, which is too expensive. If you have money to buy Moog format, go for it. Then get Moog modules to work with it. This is my point of view on it. Using Ableton CV tools, 100%. This is what I use. For example, you can look it up. I'll write it down here. It's called, it's a module that I use. It's called Expert Sleepers ES8. It's a company that makes conversion modules. Uh, it uses ADAT. So you plug an ADAT input or a USB input into the module itself. I use ADAT, and you plug in the ADAT connection into your interface, and it shows as outputs on Ableton. So you can send audio signal, receive audio signal. You can send control voltage, receive control voltage. You can make your rig control plugins in Ableton. You can make Ableton control modules that you have in the rig. It basically stitches Ableton and the modular rig both as if they are one big system. So back to sequencers. Sequencers are modules that generates a sequence of control voltages. So you want to have some pitch going on. You don't like playing, for example, a MIDI keyboard. You don't want to play with it. You just want to have uh, sequences that keeps moving and changing all the time. You use a sequence that creates pattern, rhythm, and some of them uh, produces modulation as well, that you can control various modules with it. You have your utility modules. You have mixers that combines audio or CV signals. You have attenuators. It can scale down or invert a signal. If you have a signal that's in a positive value and you want it to go into a negative value, you use an attenuator, or it's called an attenuator and inverter, such inverter, because sometimes you will have an attenuators only, but if you are buying an attenuator module, you might as well invest in an attenuator that can flip the signal to the other direction. Or you can scale it down. You can choose to reduce the amplitude. You have quantizers. Quantization in general is if you have a value and you want to lock it down to a different value, let's say, for example, you can see that all the time in Ableton, timing quantization. If you have some notes that's been a bit shifted, that's not on time, and you want to snap them on the grid, you quantize those notes. In modular, quantizers are used to snap a value to the nearest note value. So for example, you decide to the quantizer that you want the note C, D, E, F, and G. Any value that's outside those notes, the quantizer will snap it to the nearest. So let's say the value that's in is a bit off from the F, it will lock it down to the F. So whatever, you can never go wrong. Whatever values you are putting into modular, into the quantizer, it always will come according to a musical scale that you decide. You have mults. Mults are modules that creates copies of the signal. So you can use one signal. You can have, for example, eight copies of the signal. You can route them to different modules. So one function changes 8 modules at the same time. You have logic and timing modules. You have clock generators or clock dividers. Generators, it will generate a clock, like for example, one of the 8 triggers, and you can plug a copy of the one of 8 triggers into a divider, so it can give you some variations of it, like 1/8, 1/4, 1/2. So you can have from one clock, you can have different variations of those triggers. You can have random sources, like noise. You can have random modulation generators that will generate always different and random voltage values that you can use to randomize your rig for a bit. And my personal point of view, if you don't like randomness, then I think Eurorack is a very expensive option for you, because the beauty of Eurorack is the happy accidents. You plug in some controlled parameters, you mix them with some random movement that's going on, and you hope for the best. You have switches, which it's from its name, it's a switch. You route the signals to different destinations. For example, you have one signals going in, or you have 4 signals going in and only one output's going out. So you can have 4 different kinds of modulation, for example, and only one of them is being spit out. So you use a clock to, for example, every bar will change one of those inputs. So you will have an LFO at this bar, and the second bar you will have some triggers. At the third bar, it will flip to random values. So it's a way to shift the whole behavior of your rig just by a simple push of a button or with a simple trigger. You have logic modules, and this is one of my favorite. It uses and an or values or truth table, and this is something that we will explore. You give it 2 triggers, and it will give you a third kind of rhythm based on those 2 inputs, which can create a very interesting rhythms or very interesting results. You have sample and hold, which, for example, you put in a random voltage generator. Every 1/16 is giving you a new random value. Once you push a button, it will lock on the current value at the moment that you press the button, and it will give you that value, and it will keep giving you that value until you trigger it again. Then it will hold on the random voltage or the random value that's being currently working with, and it will give you that new value. So it's a way of creating control, let's call it controlled random modulation, instead of something that's changing all of the time. It will only give you a certain value whenever you press on a button or you give it a trigger. You have your effect modules, reverb, delays, distortion, wave shapers, glitch machines that you can use to sculpt the sound more, give it some flavor and taste. So by this, we finished the theoretical part. We can move now to the more interesting part to see everything in action. So for today, I'm using VCV Rack. It's a free software. It's a free software that you can find on the internet. You can have a lot of modules, free modules, and there are paid ones, and you can start using it to simulate and understand more before going and buying or deciding to buy some modular synthesizers. I will switch off my camera now because I want the internet connection to be good, so you can hear everything clear. Okay, let's start with the basics. In order to be able to patch to start with the basic patch, you always take the output, you plug it into an input. Never plug it in the other direction. Most modules now have a protection against that, but it's highly unadvisable. Sometimes you will do accidents that you will plug things in the wrong direction. Don't worry, you won't fry anything. But in order to keep your modular working, you need to always plug an output into an input. And normally outputs has a black square or a rectangle around it to tell you that it's an output. And if you hover your mouse on it, it will tell you what kind of port that you are looking at. So first of all, that we explored was an oscillator. We need to know what an oscillator does. So an oscillator will always keep running, uh, not like digital synthesizers or normal synthesizers where everything is already wired for you. You have everything on its own, so you need to start making a basic patch. So this is a scope. This is a scope an oscilloscope that will tell me what kind, like the shape it's a visual representation of the wave in front of me that whatever I'm inputting. Uh, this is a mult. I plug in something in the input and it gives me copies of that input. This is a frequency analyzer, a spectrum analyzer to tell me exactly what's happening in the frequency domain. This is a VCA that we will talk about. This is an envelope. This is a filter that we will explore. This is a mixer that we will talk more about later on, but I want this because it has a mute button. And this is an audio output. Let's call it your sound interface. So patch the system. First of all, we will take the wavetable. We take the output of the wavetable. I will put it inside the scope so I can see what's happening. The scope has, whenever I input something in the scope, it will give me a copy of it so I can use it somewhere else. So I'll take the output of the scope. I'll place it, I'll take some copies. I'll make some copies out of it. One of the copies will go to my spectrum analyzer. The other copy will go to the input of my mixer. I'll take the output of my mixer to my input of my audio interface. If I unmute, you will hear a sound. So that's a sound that's constantly running. It's a sound that's constantly running. And if we check our scope, it's a triangle wave. As you can see here on the wavetable oscillator, it shows a triangle wave, and on the scope, it shows you a triangle wave. Let's start by changing waves. This is sine wave, triangle that morphs into a sawtooth wave, and then changes to a square wave. And as you can see here as well, harmonics start changing. Sine wave will have only one fundamental, one harmonic. The more that you start changing the wave, more harmonics starts appearing, and the sound starts changing. This is a square wave, it's hairy and buzzy. Square wave, you have sawtooth wave, more harsher. You have a triangle wave, it's mellow, and you have a sine wave, which is one frequency. Moving on to the next component, it's the filter, a normal filter. So let's say now we want to include the filter in our signal chain. So To know how to work with modular, you need to excel at signal flow. It's all about signal flow. You need to imagine how your signal chain will be, to be able to plug the modular, to be able to plan for your next patch. Because you can create, like sometimes I create a patch that's so flexible that it keeps working for a month. I keep getting results for a whole month because I keep building it. It takes me 2 or 3 days of building the patch, but it can stay for a month, giving and giving without stopping. So I want to now patch my filter in. So normally, this is my train of thought. I have an oscillator that keeps. I have uh, I have an oscillator that keeps playing sound. So I want to pass this oscillator through a filter, go from the filter to the output so I can hear the sound. So if I clear all the cables, this is how I would do it. Take the output of the oscillator, goes inside into the input of the filter. I'll take the output of the low pass filter and then I'll make some copies out of it. I'll ignore the scope for now. Take a copy that goes into the frequency analyzer. Take another copy that will go to the input of my mixer. Take the output of my mixer that will go to the input of my audio interface. I'll change the wave so I can have more harmonics. Now, you either remove harmonics or you release some harmonics. And this is the East Coast approach. Start playing with the filter, you start getting sound. My third module, or the core module, which is called the VCA, or the voltage controlled amplifiers, and this is something you can never have enough of. You need as much VCAs as possible because they control everything. I use them to control everything. And what they do is that they control a signal. For example, if we take the output of the oscillator, I put it inside the input of the VCA. I take the output of the VCA, I plug it into the input of my scope, and then I take the output of the scope, plug it into the input of my mixer, which is going to my interface. Sorry for that. See, I turn down the volume. For some reason it's showing some level, but we don't have level going on. So I don't know what's happening here. Oh, sorry, I was triggering it. So I don't have anything. I start opening up my amplifier. It increases the amplitude. You lower it down. It takes the amplitude away. Decreases the amplitude. You don't hear any sound. This can work with a lot of things that we will demonstrate soon. But you need to know that this is the function of the VCA. You plug in a signal, and whatever that signal is, it will change the amplitude. You have our envelope. This is an envelope which you can find the attack knob, decay knob, sustain knob, and release knob. I have a clock here. Let's see the clock on the scope. it just outputs a trigger, signal. So you plug in the output because any envelope will need trigger signal to let it work. Because if you plug the output of an envelope inside the scope, nothing is happening. There is nothing that's telling the envelope to work. You need to poke or to trigger it or to tell it you need to work now. You need to work now. And the only way to make an envelope work is using a gate or a trigger signal. And as you can see here, the input of the envelope is telling you that it needs a gate. So we will plug our gate, which is every beat, to the envelope, and here you are. You have a shape. I increase the attack, shape changes. I'll make it snappy, increase the decay, increase the sustain, increase my release, keeps creating a voltage that you can use to modulate some stuff. Let's put everything we know now about the core modules into action. Let's see how to make a very basic patch out of what we have. So any input that you, or any controllable input, like for example, here it's called CV. As you can see that there is a small label that says CV input. That means that this input can be controlled by any kind of voltage. Doesn't matter a modulation, an audio source, anything that gives you an output can be plugged into that input. And depending on the shape of the voltage that you are inputting, it will modulate whatever parameter that you are putting this into according to that shape. For example, you have here something called cut, means the cutoff, and you can control the cutoff with modulation. You can control the amplifier with modulation. So I'll have two. I'll get another envelope. I pressed on Control D and it duplicated the module for me. So I'll take the output of my wavetable of my oscillator. I'll plug it into the input of my amplifier. Sorry, I'll plug it into the input of my filter. I'll take the output of my filter. I'll plug it into my amplifier. Take the output of the amplifier, plug it into the input of my mixer. Increase the level. Now you have sound. But now I want to control the filter with an envelope. So as we mentioned that you will need a gate to be able to trigger the envelope. So every beat, for example, let's say every 1/8, I'll trigger the envelope and I will use the output of that envelope to control the cutoff. Okay, reset this. This knob or this, let's call it an attenuator, it will allow you to, it will give you the option to how much you will control the cutoff using that signal. So let's take the envelope that we have. Sorry. Let's take the envelope, put it in a scope. Let's take the output and put it to the cutoff. So if you want the cutoff to work with the full voltage, you will move the cutoff till the end or the attenuator to the end. Or maybe you don't want the filter to open the very far end. You will let it only open to a certain amount. You change the decay. You want it snappy. You want a bit of release. not you want some sustain. Maybe you want to control the amplifier as well with a different envelope that moves every beat. For example, I'll take the beat output, plug it into the gate input. I'll take the output of my envelope, plug it into the modulation or the CV modulation of the amplifier. You can see the amplifier is now opening and closing according to this. Maybe I'll make it snappy. Maybe I'll increase the decay. Maybe I'll have more sustain. Let's hear it. It's creating now some sort of a weird uh, two beat thing that's going on because you have one on 1/8 and you have one on every beat. Maybe you want another envelope that's being triggered every 1/16, and that envelope will control the resonance of your filter. So this is a demo of the very core modules and how you can start patching using the output into the input, using a clock, how to check things on a scope. So let's move to our second file. So we have understood now a bit about oscillators, VCF, envelopes, VCA. Let's move to the LFO. Let's take a look and dissect the LFO on a scope. So take the output of the LFO, plug it into the input of the scope. You have different shapes of the LFO. You can increase the frequency, make it run very fast, reduce frequency. So let's use an LFO in a practical context. Do the normal patching route that I take every time. Take an output from an oscillator, plug it into my filter, take the output of a filter, plug it into my amplifier input, take the output of the amplifier input into my mixer, and from my mixer, I'll go to the audio interface. You can't hear sound because the filter now is closed completely. Now I can use an LFO to control the cutoff. Change the frequency. Let's try and plug to use an envelope, for example, to change the rate of that LFO. So I will use my button here that will output a gate. Let's take a look at it. I'll plug it into my scope. I, I press on the button. Every time I press on it, it gives me a high voltage as long as I'm pressing. I, I don't press it, nothing happens. So I will use this gate for my envelope to take the output of my scope to the input of my gate, take the output of the envelope, put it into the input of the rate of the LFO, increase the modulation range a bit, change the parameters here a bit. Increase the sustain. Increase the so the LFO are the hidden, let's call it hidden hands that you can use to modulate stuff. For example, let's remove the envelope. You can use another LFO that changes the rate of the first LFO. So if you have another LFO, you can plug the output of the LFO into the input of the rate or the frequency modulation of that LFO. And for example, we can take 16 notes, use it in an envelope, which I will plug into the input of the envelope. I will use it to control, for example, the amplifier that controls the sound. It's not the best sound in the world, but you got the idea. So you can use different stuff to keep moving the modulation around. You can use LFOs, you can use envelopes, you can control VCAs. Another way that you can use the VCA is to control how much of an LFO. Just a moment. So, for example, let me delete this. You have an LFO, you plug it into a VCA, you plug the VCA into a scope. Now you have a signal. The more I take out from the VCA, the LFO modulation signal disappears. Now you don't have any. Now you have more. So for example, if I get my button, I plug it into the gate of an envelope, which I will control my VCA with. Use that LFO, for example, to change the pitch on the oscillator. I press on the button. Now then it goes back to normal. Maybe you want to, for example, you want the filter to be modulated as well with another envelope. So you have 16 notes, goes into the gate. You take the output, which will change the cutoff frequency. Then I press a button. So you can use VCAs control a lot of things. If maybe you don't want something to be constantly moving, you want it to happen at a certain time. Uh, for example, using a clock, you want every bar the modulation happens or the VCA opens. So that's LFOs. Uh, let's move to the next example, then we can take a quick break. FM modulation. FM modulation, it's using one oscillator to control the frequency of another modulator, of another oscillator, telling it to go higher in pitch, lower in pitch, and it keeps moving, and it creates very distorted, growly sounds. For example, this is the output of the one oscillator. Put it in a scope, normal sine wave, nothing fancy about it. You take the output of the second oscillator, plug it into the scope, same thing, nothing fancy about it. But what happens if I take one output of the oscillator, plug it into the FM input, which is the frequency modulation of the another input? Now, let's listen to it. I'll take the output of my scope, plug it into the input of my amplifier, take the output of the amplifier, plug it into the input of my mixer. Now I have sound. Let's choose the percentage that I want this modulation to affect this oscillator and watch the scope. The wave keeps changing. Maybe it will change the shape of one of the modulator oscillator. Maybe I will put an amplifier before this modulation. So I'll take the output of the oscillator, I'll put it in the input of an amplifier, take the output of the amplifier, plug it into the FM or the frequency modulation input, and I will control this amplifier with my button. So I'll take the output of my button, plug it into the input of the envelope, take the output of the envelope, plug it into the input of the amplifier. So now you have a normal sound, normal sine wave. I press on a button, we increase some of the attack. Increase the sustain. I will tell my clock here to do the button pushing for me. for every beat, for every 16 notes. So this is FM modulation. Let's take a quick 10-minute break. And come back. We will explore more of those modules. Any questions before I leave? Hello, is everyone back? Welcome back, everyone. So I had a question here. One of you guys was trying to follow up with the modules I'm using and could not find them. Let me show you quickly how to do that. Sorry, I did not mention that at the beginning. So you go to VCV, look for it on Google, you find the website. In here you'll find the sign in. I'm already signed in. I go to the library. You choose whatever module you want. Filter with free. Press on add. Choose whatever you like from their catalog. Then once you go to the software, you go to library. In here, it will ask you for your username and password, same one you created with the account. Then you press on update, and everything will show up once you right click on an empty space here in the on your rack. All the modules that you download, you will find. You can filter through them and you can work your way. Another question, anytime, Irfan. So any other questions before we continue? Okay, perfect. So to recap what we explained, we took a look at the oscillators, envelopes, amplifiers, filters, uh, what an LFO is, what's frequency modulation. Now we will move to amplitude modulation, which is another technique. It creates a different palette of sounds. So comes from the name, amplitude modulation. You use an oscillator control the amplitude of an amplifier for another oscillator. So, for example, we have an oscillator that will go directly into an amplifier. So again, I'll take the output of the oscillator, plug it into the input of the amplifier, take the output of that amplifier into the input, my mixer, and we have sound. If I get another oscillator, let it control the amplifier. As you can see, the amplifier is going crazy right now. Creates a distortion of some sort. Changing the wavetable. Maybe you want to filter the sound. So I'll break the connection between the amplifier and the mixer. I'll take the output of the amplifier, plug it into the filter, take the output of the filter, goes to my mixer. Let me unmute it. Maybe I'll use an LFO to open up the filter. And that's amplitude modulation. You use an oscillator or something that's running on an audio rate to control how much the amplifier will open and close, which create distorted sounds of its own. It's a different kind of palette than the frequency modulation. Moving on, sequencers. This is a sequencer. Sequencer, I'm not gonna explain everything in it because everything I'm explaining today, it's just the basics. And the modules I'm using here are very basic modules. They don't do anything crazy because more advanced modules will take on every concept and they build a module on that concept to do crazy stuff to those envelopes, to those LFOs. So today it's about only the basics, how the basic core modules for each and every component work. Maybe if I'm lucky and I get the chance to give you another session, we can go to more advanced techniques. But it's today how to get a rig going and understanding more what are the building blocks of a synthesizer, of a modular synthesizer. So a sequencer is a module that will output values. In this module, it's only 3 rows, so it can give you 3 sequences. But today I will use only 1 row, only 1 sequence. And a sequencer needs a clock or needs a trigger, something to tell it to move on to the next node. So it cannot work without, it can have a clock on its own, but most of the analog ones does not have. Some of them have, so it depends on the module you're getting. But I'm gonna clock it from my clock generator here. So I'll take the output of my clock, my 1/8 node, plug it into the input of the clock, which is the clock input. I'll take the CV output, CV3, because I will use the last row. I'll plug it into the volt per octave input, which is responsible for changing notes on my oscillator. I'll take the output of that oscillator, plug it into the input of my filter. I'll take the output of the filter, I'll plug it into the input of an amplifier so I can control it, whether I want to control it in the future with an envelope or something. I'll take the output of that filter, sorry, of that amplifier, plug it into the input of the mixer, and let's see if we have sound. Open up the filter a bit. Yes, I have sound, but I have no pitch going because I did not change any values yet. But let's start playing with the note. Maybe I want 16 notes or the same 8 note to control my envelope. In VCV, you can stack uh, cables on top of each other, which you can do in real life with special cables. But it's not everyone has them. But we will use this function So I'll take the gate, I'll connect it to the 8th output so I can have the same value that's running the clock to the to trigger my envelope. So I can use it to control the filter cutoff. Always a gate, not sorry, no, the sequencers, not all of them, but most of them will give you gate outputs at certain steps. So you can see here, I'm using only 4 steps. It's an 8-step sequencer, but I'm only using 4 steps. I'm using the first one, two, three, four. And you can see at every step, whenever it will play, it will trigger an output. So you can use those to start creating some movement. Because, yeah, this is a good sound, but it's good sound. You cannot play it for more than 10 seconds. But what if I want to add some interesting modulation to it? So I'll take, for example, the third step. I'll plug it into, sorry, I need another envelope. So I'll take the third step. I'll stack it on top of the, for example, the FM sound. So at the third step, now an envelope shape will be created, which will change the pitch a bit. Let's hear it. We have a question? Yes, it means a pulse. So let's take a look at it on the scope. So let's take the gate output that we have in the scope. It just sends you a trigger, something as if you're using your finger and you're poking the envelope, telling it, hey, you need to work now. Hey, you need to do whatever you are going to do. There are other uses for it, but that's beyond today's scope. Because you have a lot of envelope modules that allows you to change or to modulate each stage on its own, the sustain, the decay, the attack. So you can use another envelope to change the decay, to keep changing. So you can have a patch that's dynamically working together. So for example, I can get another, let's get another envelope. That envelope, I want it to work every beat to change the resonance, for example. Let's change the attack and decay. That's without it. That's with it. Can change. So that's what the sequencer does. But doesn't sound very musical, right? Because it's spitting out random value, not random, but it's not precise to a single note. So we talked about this in the theoretical part, which was the, oh, it doesn't like what I'm doing. Talked about quantizers. Quantizers are modules that will snap whatever value or whatever the nearest value to the nearest value that you will decide. For example, I'm using here the root note, which whatever you will decide using the knob. I used if that's C, so the black one is a black key, which is C sharp. So I use C, D, E, and G, for example. And depending on the root note, it will play. So let's see what's gonna happen now. So I'll clock my sequencer. I'll let it work every beat. So I'll take the output of my clock, the input or the clock input of my sequencer to just give it a time depending on the BPM that you will decide. I'll take the output of the third row because I'm working with the third row because I'll use it. I'll take the output. I'll put it inside my quantizer and the input of the quantizer. I'll take whatever it will spit out because now the notes are quantized, so it needs to go to the volt per octave, which is the what will decide the note for the oscillator. I'll take the output of my oscillator, goes into the filter, take the output of my filter into the input of my amplifier, taking the output of my amplifier goes into the input of my mixer that goes to my audio interface. I'll use 4 steps just to keep things simple. Change the values. Maybe I'll run it on a faster. Maybe I'll use 8 steps. Change the wave. Maybe I'll use one of these steps to trigger an envelope. I don't have an envelope. So I'll use this step, for example, to open up my filter. So I'll plug the output of this step, a gate of the envelope. I'll use it to change the cutoff. And that's quantizer. So if you want to make melodies, you want maybe, for example, you're not an expert on music theory and you want to play some notes on a MIDI keyboard, and you take that data or the voltage coming from the MIDI keyboard, you will pass it through a quantizer. So you make sure everything you play is in scale. This is what you can do with it. And advanced sequencers, uh, they will always have a quantizer inside the sequencer itself. For example, there is a sequencer that I'm saving for. It's called Metropolis. So it has the quantizer integrated inside the module itself. You just assign a scale, you choose a scale, and whatever values you will give, it will be a scale will be locked to that scale that you decide. But the one I'm using now is a very basic one. It's not something fancy. You just use it, put it inside an quantizer, and use it on a VCO. Moving on, attenuators. Attenuators are just modules that scale a signal. So, for example, you have now I have one beat going to my button. I'll take the gate. Let's take a look at the gate. Just a normal gate, nothing fancy about it. If I pass that gate through my attenuator, take the output, put it in the scope so I can check what's happening. So now I'm at 0. As you see, the knob is in the middle. So it attenuated the signal to 0, nothing's happening. If I move it to the right, I'm increasing the amplitude. If I'm using it to the left, I will flip the signal. And I use that to, first of all, obviously to attenuate the signal. If I don't want a lot of signal that's going on, I just need to attenuate it a bit. Or, for example, if I have a gate, I can take uh, the gate, take a copy of it, send it somewhere to activate something, and maybe at the same time, I want an amplifier to close. So I'll take another copy of the signal, pass it through my attenuator. Let's look at it. So now it's creating two signals, one that's high in voltage and the other one is low in voltage. So maybe you are triggering something, and at the same time you are triggering something, you are closing an amplifier with another signal. So you can create some dynamics. For example, some people use it as a ducking technique, or if the kick comes in, the bass will duck. Maybe you want some kind of modulation signal to stop once the trigger signal comes in. So you can use it in very interesting ways. If you copy the same signal, you invert signal, so you will have a copy. So you have a clean signal and you have an inverted copy of it to do something that's opposite of what you are intending to do. Um, it's very handy to have in your rig. Of course, you have function generator modules that has this in it. For example, if you watch any modular synthesizer video, you 99.9% you will find this module in it. Uh, Let me get a bigger picture. This is one of the greatest modules ever built, and it has 4 attenuators, and they are all mixed to one output. So you can put in 4 signals, and then you can attenuate some of them, you can flip some of them, and they will all get summed into one signal that's constantly changing depending on the value uh, that you are giving it. So you can buy them on their own, but you can get dedicated modules that has them, including some other cool features that can help you with changing your sound constantly. Uh, Moving on, mixers. And this is a very interesting topic because with mixers, you can start, instead of mixing only sounds, you can start mixing control voltage signals. So, for example, let's take an LFO, plug it into one channel, take another LFO, mute 3 channels, take another LFO, uh, plug it into a second channel, take my envelope, plug it into a third channel. I need to trigger my envelope. and let's take a look at the output. I'll unmute my first channel, which has a sine wave LFO. As you can see, sine wave LFO, nothing fancy. Second channel has a blend. Let's keep it clean. Sawtooth wave LFO. Let's take a look on my envelope. My envelope is having something with a bit of attack, some slow decay, no sustain, some release. But what happens when you mix the three together? So sine wave, I'll mix in the sawtooth wave with it, creates a weird shape. Now you mix in the envelope. Maybe I don't want too much envelope in it. I'll just dial the envelope down a bit. Let's hear it in action. For example, let's take the output of my oscillator, plug it into the input of my filter, take the output of the filter into the input of my amplifier, take the output of my amplifier, plug it into the input of my mixer, which has a mute button, and it goes straight into my interface. So filter, let's plug in this weird modulation that we created. Let's change the frequency on 1. Sorry for that. It does that for some weird reason. Let's take the same modulation. Uh, yeah, actually, we can use an attenuator for that. I'll take an attenuator. So I'll take the output signal. I'll make a copy out of it. One of it will go to my cutoff. I'll take another copy that goes into my attenuator. Take the output, change the pitch on an oscillator, but I will do it in the opposite direction. So if the signal is changing the cutoff to a higher voltage or to a higher value, the pitch will be changing in a low towards the lower frequency portion. Let's why it's acting like this. It should be inverted. Oh yeah, I understand. Sorry for my this mistake, because if you take a look at if you check the scope here, most of my modulation is going down. So when I flipped it, it actually it flipped to the other side, which caused the frequency to go up. So I need to rectify this by increasing the frequency modulation and flipping the inverter. So one modulation is opening up the filter. The same modulation inverted is scaling down the frequency towards the lower portion of the frequency spectrum. Maybe I'll add an envelope. Maybe I will. So so now you see you have a very interesting modulation that's going on. It's not the same as one LFO. You mixed in inside the mixer, you mixed three control voltage signals. You used an attenuator with a copy of the signal. One of them is pushing modulation towards a higher voltage setting, and the same signal is flipped to move it toward a lower voltage setting. So by having a modulation signal that's completely changing all the time, the sound now became more interesting than having just one LFO running up and down that you can get bored of after a minute or so. So this is the use of a mixer. I use it all the time to start mixing in modulation that's happening. Maybe you don't want, for example, uh, let's uh, let's use another VCA. Let's use the second channel, pass it first through the VCA. So, and the output in the mixer. So now the uh, the signal, but it has only one shape. If I open up my amplifier, it will slowly start bringing in the second modulation. So maybe I will use another envelope. I'll take my button output, gate input on my envelope that goes into the amplifier, and I press on the button. Now it brings in the modulation slowly, and nothing is happening. Oh yeah, interesting. So we have a question. What we have now is not an additive synthesis, because an additive synthesis will require that you add harmonics. Actually, I am using a filter and I'm changing pitch. So this is subtractive synthesis. Additive synthesis will be if uh, I'll get another oscillator, and instead of changing the pitch using an LFO, now I will use the output of one oscillator to change the pitch of another oscillator, which will force it to create more harmonics. So you can see this is without it. This is when I start adding in. Nice drum bass sounds, yeah. Maybe a bit of dubstep. So dubstep, for example, and drum bass, they use tons of frequency modulation. Nearly every sound has some frequency modulation on it. So remember, additive synthesis, it creates more, you use it by adding more harmonics, which involves a bit of another oscillator controlling a pitch from an oscillator to another oscillator, or an oscillator controlling an amplitude of another oscillator, or maybe adding more sine waves to it. Anytime. Any other questions so far? Okay, perfect. So, yes, to recap, mixers. So mixers, you use them to mix all sorts of stuff. You can mix in audio signals. Maybe you have two oscillators. That's demonstrate that quickly. I'll clean it up to keep it a bit simple. So I have two oscillators. I have one that's going into the mixer. I have another that's going into the mixer as well. But first, uh, yes, for example, like this, I'll take the output, I'll plug it into an input of a filter, take the output of the filter, plug it into the input of an amplifier, and now I have two oscillators mixed in. So if you have two oscillators, you can have two melodic sounds, for example. They are both mixing together, creating a new sound. And you start. So you can use them to mix oscillators together. You can use them to mix modulation signals together. It's always a tool to create something new out of some existing signals. Moving on. Clock dividers. Question. Exactly. That function, both of them will collide and both will create something new out of it. Maybe you will have two melodies getting inside, so both will add on each other. Maybe you will. Okay, let's go back one step. So this is a. So you have two oscillators, two envelopes. Let me demonstrate it in the second one because it will be a nice example with the divider. Clock dividers is a way to get several sequences that's coming derived from one rhythm. For example, I'll take the output of my one beat. I'll let it push a button because it gives me a longer gate to work with. So nothing fancy. You get a gate that's happening every beat on 120 BPM. If I take uh, a copy of the signal, so I'll take the output of my button, plug it into a multiple, so I can have 8 copies of the same signal. Take one clean output, same trigger, nothing fancy. So I'll take a copy of that output, place it, plug it into the input of a clock divider. Now I have some values. So it will divide this on 2, 4, 8, 16, and 32. Let's take a look on the divided by 2 in comparison with the original signal. So I will plug it into the second input of my scope so I can have two signals. You have a gate that's longer and which is 2 times the original gate. Let's check the 4. We'll have a gate that's 4 times longer than the original gate. So now you have a trigger and you have a trigger that's 2 times the time that this original trigger is taking. Let's put that into context. For example, you have two oscillators, you have two envelopes, you have a mixer. So I have my clock pushing a button, it goes into a copy. I'll take a clean copy to trigger one envelope. I'll have another two PCAs with me. So I have let me start from the beginning. So I have a clock pushing a button, spitting out a gate. This gate, I have a clean copy out of it. I have another one that's I'm dividing. So let's leave it like this for now. I have two oscillators. I will take the first oscillator to my first amplifier, take the output of that oscillator, plug it into my mixer, take the output of my mixer, plug it into the filter. Filter goes to another VCA. VCA goes into my mixer that's going into the interface. I hear a sound. It's my first oscillator, nothing fancy. I'll mute this channel. I'll plug my second oscillator into my second VCA. I'll take the output of that oscillator, plug it to the input of my second channel. I have second sound. I mix both together. I get something which is the result of both of them adding or mixed together. But let's say I don't want them both to be playing all at the same time. I want one of them to come in and the other one and finishes early, and then the other one continues for a bit and then finishes, and then this repeats all over again. So I'll take my first clean copy of the trigger. I'll trigger my first envelope, take the output of that trigger, sorry, output of that envelope to trigger my amplifier. Now, you have a rhythm. I'll take a signal that's divided by 2, plug it into my second envelope generator, take the output of that envelope to trigger my second my second amplifier that has my second voice in it, which will do this. Now I mix both together. So you have a sound that comes earlier than the other, and the other comes a bit slow. So it's creating now a mix of both. So you have like two rhythms or a bit of a more of a complex sound like mixed into one. Maybe I will have another envelope. I will let divided by 4, a division of 4 triggers that envelope, and that envelope will control the filter. So I can have the filter moving on a very much slower rate than those two rhythms. So using one trigger with different divisions for it, controlling different envelopes. Each envelope, one of them is opening up a sound, the other one is opening up another sound at a different rate. Both of them are mixed, and then you filter all of them with a third envelope that's moving on a different rate. Now you started creating a complex sound that's the result of three different types of modulation happening at the same time. Put in a sequencer, put in some LFOs that you can mix in a different mixer. So now you start shaping or start creating a machine that keeps constantly moving around, creating whole types of textures that you can work with. I can see that we have a question here. A mixed signal. The mixed signal is the signal. It's just two audio signals working together. See, because I'm adding in the sound and I'm removing it, so the audio signal keeps moving. Did I answer your question, or do you mean something different?
So actually, I wanted to know the final signal chain, the end of that signal after the
How it
final
look like?
VCA.
Okay,
Yeah, yeah. From the final VCA, I would like to see the scope because it will kind of demonstrate the final uh, uh, how I can how what changes that you're making are shown visually.
sure.
Okay, so thank you.
You're welcome. Actually, I like the sound. Maybe I'll get a third, a fourth envelope. I'll use a 1/8, sorry, divided by 8 division to trigger the envelope, which will change the resonance. And let's see what's going to happen. So now the sound started getting a bit more complex. You can hear a lot of things that's going in the background. Two voices with filter modulation, with resonance modulation. Uh, Maybe we can get, let's just for the fun of it, we can get a fifth envelope. We can use a 1/16 gate to change the pitch on one of the oscillators. Let's hear how that sounds. So you start with a simple module, and then you start slowly, a bit by bit, adding, and all of a sudden it will be very complex. So well, when I got my system, and I never got get anything good out of it, and it was very frustrating. But I realized that I need to work very slowly. I need everything to move. Yes, you can move things quickly. Some of them can move quickly, but you need as well to have very longer modulations that will, because the moment you start adding modules, the more one change or one small change will affect a lot of things because everything is connected. So the slower you work, you need to have a wide range of modulation signals. Some of them that's running fast, some of them that's running really slow. Instead of having everything in one speed, the more variety you will have of modulation and of modulation rates, the more you will get out of your rig. But this is my point of view on it. There are no rules, absolutely no rules when it comes to modular, and that's the beauty of it. That it takes you to new territories that you couldn't think that you can reach with normal synthesizers. You can do all of this, of course, but you will need four serum to have like you can. Serum has what, three oscillators, four oscillators. Here you can have 16 of them. In serum, for example, you have 8 LFOs. You can have here as much as you can, and in real life you can have as much as you can afford. So you have really no limitations when it comes to modular synthesis. So that's why at the beginning I mentioned if you are someone who's a bit of a control freak and wants a specific sound, yes, you can get modules that dedicated for that, but where's the fun in it? If you don't want to explore new sounds or to go places where you never thought you would go to, then yeah, invest in a modular system.
So,
Moving
so,
on.
so,
Yes.
so is this kind of a system processor intensive or process intensive? I mean, because of the restrictions some may have with the system that they are having. I mean,
Which one? A real
I
life
mean,
one or
I
the one I'm using
no,
now?
no, this kind of a software based one.
Well, it depends actually on your processing. So on top of the screen here, you will have some values that's telling you how much you're consuming from your processor.
Uh-huh.
So it actually depends. And if you invest in buying the VCV Pro, there's a Pro version.
Uh-huh.
It comes with a VST that you can load inside any DAW. So you can have
Uh-huh.
those sounds working inside of Ableton, for example, Pro Tools, Cubase,
Mhm.
pick your poison. Uh, so
So I
it
mean,
depends on.
yeah, they're saying that it's really light when you're using Serum. It's really light on your processing and all. So basically,
100% because with Serum, for example, it
mm,
has oversampling and it uses a lot of
mhm,
processing. So yes,
yeah,
VCV is light, and
mhm,
actually it's very useful because, for example, you have some modules here. For example, if you search for MIDI, you can have MIDI mapping. So if you have any MIDI knobs or anything, you can assign any of the knobs to a MIDI
mhm.
controller that you have, and you can start playing around with it. So
Uh-huh. So you
it's
can
very
play on
useful
top of
and
it,
it's
right?
light. Yes, yes,
Yeah,
yes. You
that's
can
good.
have one knob that's controlling several knobs. So actually, it's the best representation to the real world there
Mm,
is. It's just you're using a mouse and the keyboard, which is
yeah,
there's nothing bad with it. But
yeah.
the real thing,
This is
it's
the next
as
level.
well
This is the next
the
level thing
modules that
from
you
them.
invest
Yeah.
in, they take every
Mm,
concept that we talked about today and they build an amazing module built on that
yeah.
concept. So you get an
Yeah.
envelope that has, for example, I have a module called Quadrax. It's like four envelopes inside one envelope module, and they can both
Oh,
work together. You can send one trigger, and then it triggers each. Like the first envelope will finish, then it will
mm,
trigger the second on its own, and then the third, and then the
mm,
fourth. So you can do four things in sequence. So what you're paying for in real life
mm.
is the magic that each company puts in
Yeah.
their modules.
Uh-huh. Okay, thank you,
I,
sir.
you're welcome. So moving on, sequential switches. This is an interesting thing that I like. So this is a switch, nothing fancy. It has this one has four inputs. It can only spit one output at a time. So, for example, let's take an eighth note. plug it into our let's go crazy. Let's take 16 nodes, plug it into our divider. Let's check each output on its own. You have one that's outputting divided by 2, which is 1/8. You have another one that's a bit longer. You have another one that's a bit longer, and so on. So what I will do, for example, I'll use the divided by 2, plug it into the first input, divided by 4, plug it into the second input. Sorry. Divided by 8. You know, I'll copy the 16 nodes. Take one of the copies to the divider. Take a clean 16 node to my switch, and then I'll use 4 steps. So now I have 4 inputs. I can only get 1 output. So every bar, I'll take the output from the clock that says bar. Every bar, it will move my sequence. It will give me one of those 4 inputs. Let's check it out. So you have 16 nodes, and then it will spit out 88, and then spits out 4, and then 16 again, so on and so forth. Let's hear it in context. So I'll take the output of my oscillator. I'll use it as an input to my filter. Take the output of the filter, use it an input for my amplifier. Take the output of my amplifier, use it as an input to my mixer. I have a filter. So I'll take the switch's output. I'll use it to trigger my envelope. I'll take the output of that envelope. I'll use it to control my filter. So you created a rhythm now, the same sound, nothing fancy. So you have 4 different triggers running at different rates, but you can only get one output of them that you can choose, that can change over a bar, every beat, whatever trigger you give it. Maybe you push a button and it changes that. And it does not only work with rhythms. You can use, for example, uh, let's remove this. Let's remove this. Let's remove this. So let's get an LFO. Let's get 4 LFOs. You have each LFO going to your switch, output of the LFO, input of the switch. I'll have the second LFO running different wave, third LFO wave, different frequencies. And every bar, I want the switch to give me a different input. Check the scope. Every bar, it's giving me. So let's modulate our cutoff. Maybe I'll change the pitch. So switches are very useful to change the whole behavior of your rig. So you will have 4 different inputs, and every once in a while you will send it a trigger that will change the complete behavior of what you have, a different modulation, a different rhythm. You can have two switches, like for example, uh, let's get another switch. Let's get a divider. So let's get mult so we can have copies. I'll do what I did with the previous example. I'll take the 16th notes. I'll plug it into the input of the mult. I'll take a clean signal that will go into one input of my switch. I'll take the other, say a copy, which will go into my divider. The divider will give me divided values that I will use on my switch as well. I need an envelope such as the one that we used in the previous example. Now I'll take the output from the second switch, goes to the input of my envelope. That will change the cutoff, and I will tell the switch to be triggered every bar as well. Let's hear what's going to happen. Something, oh yeah. Change the value on an LFO. Switches can create a lot of variations, and you can change the whole behavior with just one trigger. You plug in several inputs, and you can have a whole variety. Mix that with a sequencer, and you have like for example, let's while we are on topic, let's get a sequencer, for example, in here. That sequence is 4 sequences. I will use a clock every beat to clock that sequencer. uh, I'll use the output of the third row to change the note value. That's here. So you can see how you can change everything just by having some variations that's working together. Moving on. We have only 2 examples left, and we're off for today. You have the logic modules. So logic modules. In here, I'm using something called Euclidean rhythms. I will not get into it too much. It's just a way of creating very interesting patterns. If I take the output of the Euclidean module, put it in an envelope, uh, listen to what it's doing. If I change some parameters, for example, yes, it's a nice rhythm, but 1 minute and you will get bored. So a logic module, it's a way of combining 2 triggers together, and based on a mathematical equation, it will give you an output. So let's take a look on each and every. I'll take one beat, every beat, to clock my button. So this is the button gate on its own, nothing fancy. This is the gate that's coming out of my Euclidean rhythm. They are playing at different times. What if I want to mix both of them to give me one rhythm that's a mix between the two rhythms? This is where the logic modules come in, and, or, and XOR. I won't explain the XOR, I'll explain the and the or. So I'll plug in my my first input signal. I'll plug in my second input signal. The AND will only give you a trigger if the two sequences you're putting as an input are playing at the same time. If every one of them playing at a different time, it will not give you an output. So if there is a moment that those two triggers are playing at the same time, the module will give you one trigger. And let's take a look. Only one trigger, but that trigger, let me put another scope so you can appreciate this more. So I'll take the first trigger, put it in the scope. I'll take the second trigger, I'll put it in the scope. I'll take those two triggers, them in the logic module. Sorry. And I will look at the outcome with a second scope. See? When they both hit the same moment here, it will give you one trigger, which is a mix between the both rhythms. So let's hear it and let's see how it works. So I need to remember. Yes. Change the length on one. Sorry, this is not working as I intended. Let me go back to my file. So what's happening here? Every beat that's going into the logic module, I have the Euclidean rhythm is going to the input of the logic module. I'm taking an OR signal. An OR signal is a signal that either like it won't give me a trigger if both of them are playing at the same time. If any of them is playing, it will give me a trigger. So it's a mix of both of them. And this is the outcome. Let's play each of them on its own. This is the second trigger. And this is the first trigger. And this is both when I combine them in a logic module. I have a second envelope here that's changing the pitch. I'll use the AND output. Trigger that envelope to change the pitch. So it's a very nice way, and I use it a lot to create different rhythms. To have, for example, two rhythms that's playing two separate things, and I will have a logic the relationship between them to trigger another envelope that does not happen all the time, that's being triggered whenever there is a relationship between both of them. So it creates triggers that's in harmony with the two rhythms, which you can use to trigger more envelopes or other stuff with it. So you would have modulation that has a relationship with whatever you're having that's going on. It's a big topic, and to use it in a more complex setup, it will require another session because the uses for it are unlimited. It's like in every patch, I must have at least 2 or 3 logic sequences that's running because it gives life to everything. It keeps everything interesting, and at the same time, it's not a random thing that's happening. It's something that's always related to whatever the clock is doing. So it keeps everything in context. Moving on to our last example, it's called sample and hold. And as we mentioned before, a sample and hold is something that will take any value that's running through it. And whenever you give it a trigger, it will lock onto that value and will keep holding onto it until you give it another trigger. So, for example, I have here a noise generator, white noise. It's all frequencies playing nearly at the same time. But if I plug the white noise into the input of my sample and hold, and I'll give it a trigger every beat. So every beat, it will check whatever value it has in that beat, and it will lock onto it. Let's do it every bar so it can be more clear. And let's check it on the scope. So as you can see, the line is giving me different values every time beat comes in. Let's switch it to 1 beat. So instead of having everything playing once at the same time, it's giving me a new value every beat comes in. To let you appreciate this more, so let's take an oscillator, plug it into a filter, take the output of the filter, plug it into an amplifier, take the output of the amplifier, plug it into my mixer. I have sound. So let's take those random values and change the cutoff with it. Maybe we can make it every 1/8. Maybe if I get multiples of the same signal, I'll take this random, take some copies, take the same first copy to the cutoff, second copy to change the pitch. It's not so musical, so what comes in mind now that I will get a quantizer, I will use only a major scale, which is the white keys only. I'll plug the output instead of going into the pitch. I'll run the random values through the input of the quantizer, take the output, put it into the volt per octave, and I'll start getting some random melodies. Number 16. course, it's chaotic, but if you limit it down, for example, for 2, 3 notes. So a sample and hold is a way to get random values going on. You can use them to introduce some random modulation in some modules that you are using. It's a great way to keep things interesting. Uh, Maybe you can use it extensively to have something that's completely random, that's completely doing some crazy stuff. You can use it in moderation. It's entirely up to you. It's a tool in your arsenal that you can use. That's one of the tools that I use to introduce some random flavors to my patches, along with some controlled aspects, so I can keep things interesting. And that's what I mentioned with creating a patch that keeps on giving, because some aspects of that patch is random, so it keeps changing all of the time. So you can never predict the outcome. Sometimes you get very happy accidents out of it. Sometimes it doesn't sound so good. But at the end, you will get something that you keep exploring, and it's not something traditional that you know exactly what you're looking for. And that's what I like about modular, that I can keep wandering in sonic palettes for hours, uh, listening to whole new tones, whole new sounds that I never thought I would be able to do with just trying to plan which modulation I'm using and just plug in and pray for the best. That's one of the things I'm fascinated about with modular. So, any questions so far?
Most of the times, it's kind of random, no? When you're doing a modular thing, I mean, you plug in several things together, and you just looking into what will be the result of that, right? That's the main approach of this kind of synthesis, isn't
100%.
it?
Again, it's not the
Yeah.
only approach. Okay.
Mm-hmm.
You can have an
Mm-hmm.
approach that's completely planned. You can have an approach that you know what's
So
going to
you
happen
can you
with.
target some end result and work with that kind of a mindset to go with one kind of a signal flow or something like that. Can you do that?
Yes.
Uh-huh.
Sometimes I do patches that's very controlled and well behaved.
Mm-hmm.
Sometimes I decide I'll do a very random patch.
Mm-hmm.
Sometimes I choose to have a balanced approach, which I have the control over the melodies, but I have the modulation for the filters are a bit random. So it's an exploration thing.
Mm-hmm.
There's something called concepts. You need to think of a concept before building a patch. For example, you can say my today's concept is up and down. What's up and
Mm-hmm.
down? So you will have LFOs that's going up and then going down, and then you copy
I
a
see.
bunch of them, and then you start plugging them different places. You can have a concept of total chaos. So you get
Mm-hmm.
a bunch load of random modulation and you just plug them everywhere you can find and see what's going to happen. So there is no one thing that you will work with. It's every time you decide, but you need to plan ahead. So today I'll do a very well behaved patch. Tomorrow you will think, no, I'll do something random today. Maybe I'll do something in between. So this is what I found fascinating about it, the flexibility of trying new stuff. And the best sounds I made in my life were sounds that I made when I plugged a lot of things together and see what's gonna happen.
Yeah, thank you, sir.
You're welcome. I have a question here. Yes, are your rack modules entirely analog? No. You have digital modules and you have analog modules. For example, one of the best, let's say, oscillators that was created, but now it's discontinued. It's called Braids by a company that's now out of business. It's called Mutable Instruments. This is a digital oscillator. in a Eurorack format. You have DSP modules by a company tip called Tip Top Audio. It's it's a module that you get a memory card, and the memory card has effects on it that you buy, and you plug those memory sticks in, and it's a digital effect, but with tons of parameters. No, not only analog, you have a lot of the digital modules out there. It's one thing. Let me look at the other portion of the question. You have, for example, sequencers, like the sequencers that I'm saving for. It's called Metropolis. It's a digital, just a moment. It's a digital sequencer that has tons of interesting functionality. Like, for example, you can send a trigger and it can play the sequence in backwards, or it can play it in a ping pong manner, depending on the value that's going in. You can change the behavior of the sequencer. You can mute notes. You can change the pitch. It can do internal modulation, and that internal modulation can be given to you on a separate output. So you have a bit of both. You have complete analog modules, and you have digital modules. Is there a risk of equipment frying or being damaged from internally generated signals if we patch it incorrectly? No, because the modules always will tolerate. So any module will spit out up to 10 volts, and all the inputs are designed to be able to work with 10 volts. And actually, there's something called intermodulation. Intermodulation is sometimes you can take an output of of a module and plug it into an input in that module to make the module modulate itself. It is some sort of modulation that's well known, but this is a bit more advanced. Like, for example, let's see if we can do something here with this. Uh, Honestly, I can't think of something to do with the basic modules, but I most of my modules I can intermodulate it. I can make it modulate itself, which creates a whole new world of sounds. So no, you cannot fry your equipment if you intermodulate it. As long as you plug an output into an input, you're good.
So
Uh,
most of these modules are, kind of representing the actual analog module, kind of, real life module, right? Some are there,
yes.
some are of course digitally made, but most of them are actual real life modules, right?
Yes, and now a lot of manufacturers are creating VCV
Mm-hmm.
emulations for their modules. So regarding, for
I
example,
see.
the module that I was showing you that's called Braids, there is a free uh, digital emulation here in VCV.
Mm-hmm.
Okay, it has tons and tons of sounds. Let me patch it very quick for you. You have the output goes into the input. Uh, you have you have
Mm-hmm.
formant
Presets, right?
filtering.
Uh, wow.
You can have, for example, this is if I plug in a a random signal into I set it on a mode where it will change the wave if I plug a random voltage into the FM. So let me quickly create. So I need a noise module, and I need a sample and hold. So I'll plug the white noise into the sample and hold. I want a new value every eighth note. Now I plug it into the FM. I give it So you have a lot of good emulations, including a lot of good effects modules. I did not go deeper into that today because, yeah, you know, normal reverb, phaser, flange, and all that stuff. But you get modules that really takes those concepts to and push it to another level.
Okay, thank you,
So yeah,
sir.
you're welcome.
Yeah.
Any other questions? Okay. Thank you very much for having me today. I was talking to Max about the possibility, if you are guys interested in creating a Discord channel where we can discuss all of those and more on that channel. If you are interested, let Max know. We can definitely set up something like that. Hope to see you soon, guys.
Thank you.
If you
Thank you
like
so
what,
much, Mahmoud.
you're
Thank
welcome.
you. Thank you, man.
Any
Yeah, like
questions?
Mahmoud said, we can set up something like that, something that is collaborative, so anyone can you know, work together. I think Satir has asked a question. Tips
Any tips
on
to use? 100%, yes. But honestly, this is a topic on its own. To be able to use everything we learned today to make a song out of it, you will need to use switches for different sections. Like for example, after 16 bars, you will send a trigger that will change a sequence. You would send a trigger, for example, every the next 16 bars will send another trigger that will trigger a different kind of modulation or a different kind of sound that comes in, and then it mutes another sound. So yeah, it's definitely a thing. I use it all the time. I stopped arranging music on Ableton. I do this now. Uh, do different sections uh, on its own. Like I have a channel only for the pads, for example, a channel for the melodies, a channel for the decoration behind, and every 64 bars or every 32 something happens that goes, for example, to a switch that changes the whole behavior that takes me into another section of a song. But honestly, this is a topic on its own. So we cannot do this today. I hope I answered the question.
all right. Thank you so much, Mahmoud. And if you'd like, if students are also interested, we can go for like a different session as well another day.
100%. 100%.
Yeah, if you guys are interested, let us know. And
Yeah,
we'll
sir,
arrange something.
actually, it will be fantastic if we can move on to another session as well. You know, this is so fascinating.
That's great. Again, thank you so much, Dabbous. I mean, to take time out of your day to come and teach us something that's really, you know, really fun and interesting. And I hope
Thank you all
everyone.
for the. Actually, thank you very much all for giving us the opportunity to see this and learn this as well. Thank you.
100%. Just
Dabbous.
Max will set it up.
Yeah, let's
And we
organize
can
something
definitely do
another
that.
day. Yeah. Yeah, thank you so much for everyone who joined. And I see you guys in the next session then. We'll set something up. Thank you. Thank you again, Dabbous.
Thank you. Thank you, everyone. See you.